Can you put the YouTube link? YouTube link. Check the voice. Perfect.
As talks.
Are you audible? Can you speak, Upuna?
Yeah.
If you speak, we'll check whether your voice is coming.
Should I just read the questions, sir?
First question. Okay? Right. Good evening, everyone, and welcome to today's wonderful evening with Dr. Bharli Bharadwaj. Studying alone is the most boring job, and some amount of respite we need to have with a student-to-student revision. Thanks to Dr. Mithila for preparing and coming to this class. And as a NEET PG aspirant, the main role of teacher is to help you, facilitate you to do a rapid revision. More than teaching, analyzing, there is very little to do that. So, Anamika, Sush, and many more. Can you please punch? Is the voice loud and clear for all of you? Anamika, Sush, and everybody. Can you please punch? So, let's make the great beginning, doctor. What is the mechanism of action of Corynebacterial diphtheria?
It's the inactivation of elongation factor, hence preventing protein synthesis, leading to cell death.
Very good. So it is the inactivation of the elongation factor. So what is the mechanism of action of exotoxin A of Pseudomonas?
Same as Corynebacterium, it's inactivation of elongation factor 2.
So it is the inactivation of the elongation factor 2 is what you need to remember. What are the organisms that produce Exotoxin?
It's Shigella and enterohemorrhagic E. coli.
Very good. It is the Shigella and enterohemorrhagic E. coli is what you need to remember. Shigella and enterohemorrhagic. How does Exotoxin work?
Sir, Exotoxin enters into the cell via a virulence plasmid. And once it enters into the cell, the macrophages recognize it and it is phagocytosed. And then apoptosis occurs, it spreads into the cell. It's actually a non-motile organism, sir. But once it spreads into the cell-to-cell transmission is by something called as an actin, sir. It's a stress receptor in between two cells. So through actin, it pushes into the other cell. So it's something which goes into the cell.
Very good. So
Exotoxin is being produced, sir, and then this enterocyte recognizes the Exotoxin. Then cyclic AMP levels increase into the cell. Cyclic AMP attracts water from the vascular system, and it also activates something called as cystic fibrosis receptor, sir, that allows the chloride to push out. So along with chloride, even water escapes. And what Shiga does is, it doesn't allow, normally whenever you have an abnormal stimuli, some amount of cyclic AMP is being produced, but it stops after some time. But with Exotoxin, it attaches a ribosyl group to that particular adenyl cyclase G protein coupled receptor, and it keeps it open permanently. So more amount of cyclic AMP leading to watery diarrhea. It's the mechanism with most of the organisms causing diarrhea.
Very good. So fundamentally, it is the 60S ribosome is the one which is the key factor which is inactivated whenever the Shiga toxin is working. Now, what are the clinical effects of the Shiga toxin?
You have dysentery. It also causes HUS, I think so.
Yes, it leads to dysentery, it will enhance the cytokine release, it causes hemolytic uremic syndrome.
There's one more thing Shiga causes, sir. It's called as Ekiri syndrome. So it's a very rare phenomenon. It's lethal. It's an encephalopathy. So EKIRI, Ekiri syndrome. Even that is possible with Shigella. That's like very lethal.
Very good. So O157H7 of EHUC and Shiga, both of them, they lead to the development of hemolytic uremic syndrome is what you need to remember. Very good. Now, doctor, how does Shiga, even Shigella, Shiga toxin, EHEC, both of them are similar. But is there any difference between them?
Yes, Shigella enters into the cell, but EHEC attaches to the cell surface. It doesn't invade the cell.
Good. So EHEC does not invade the host cell, unlike the Shiga, is what we need to remember. Now, what is the mechanism of enterotoxigenic E. coli toxin?
ETEC has produced two types of toxins. One is heat labile, another one is heat stable. So how I remember is heat labile, A comes first in labile, so it causes increase in cyclic AMP. But whereas heat stable causes increase in cyclic GMP. There is imbalance leading to diarrhea, traveler's diarrhea.
So there is a heat labile toxin LT, which increases the cyclic AMP, heat stable toxin that increase the cyclic GMP that lead to motility diarrhea is what you need to remember. Now, which bacteria increase the cyclic AMP?
CAMP, CAPE, CAPE. That's how I remember, sir. So it is cholera, anthrax, pertussis, and E. coli.
Very good. So cholera, anthrax, pertussis, E. coli. What is common to all of them is they all increase the cyclic AMP. Is one of the favorite questions of the examiner. So, very good. Dr. Joshi says it is very clear. Sugandha Joshi. We have one more Joshi over here. So, a lot of Joshi conversations. Mithuna Joshi and Sugandha Joshi. Anamika Sharma. So, she is saying, sir, your voice is getting resounded. Is it? Manu, can you please check? So, she is saying that voice is resounding. Is it? Can you please close this door? Can you close this door? Okay. See, when I am speaking, no? Mitra, you need to mute your mic.
Oh, okay, sir.
Just you need to mute your mic. When you speak, when she speaks, I need to mute her. Oh. Okay, no problem. We'll do that. All right. All right. Just we need to toggle with the this thing. Suresh, can you do the muting? When I speak, you mute her mic, and when she speaks, my mic. Can you please do that? Huh? Okay. All right. What is the mechanism of action of cholera toxin?
I just confused Shiga with cholera. So Shiga is like 60S ribosome. It removes the adenine group. But with cholera, whatever story I told previously that increases cyclic AMP, That's the thing for cholera. It permanently keeps the G-coupled protein adenylate cyclase open.
Very good. Very good. So it overactivates the adenylate cyclase by permanently activating the GS, causing voluminous, rice water diarrhea, is what we need to remember. So, what is the mechanism of action of anthrax toxin?
Um, Anthrax, sir, pathogenesis is like anthrax has a capsule around it. It's a gram-positive bacteria. So the bacterial capsule prevents phagocytosis, and it also produces exotoxins. And there are three exotoxins produced. So one is elongation, one is edema factor, second one is lethal factor, and the other one is protective factor. So protective factor, it facilitates the entry of anthrax into the cells. The edema factor increases cyclic AMP, leading to edema around the eschar borders, and lethal factor causes necrosis.
So, it mimics the adenylate cyclase, it increases the cyclic AMP and cause the edematous borders of the black eschar, is what you need to remember. So, what are all those bacterial exotoxins that inhibit the protein synthesis?
Bacterial exotoxins are Corynebacterium and Pseudomonas, Shigella, and Enterohemorrhagic E. coli.
Which bacterial exotoxins increase the fluid secretion?
It's enterotoxigenic E. coli, anthrax, and cholera.
Good. Which bacterial exotoxin inhibits phagocytic ability?
It's a Bordetella, sir.
Very good. Inactivation of the elongation factor is the mechanism of action of which bacteria?
This is a repeat again, sir. So it's Corynebacterium diphtheriae and exotoxin A of Pseudomonas.
Very good. It's the Corynebacterium exotoxin A of Pseudomonas aeruginosa, which typically are associated with inactivation of the elongation factor 2, is what you need to remember. Now, which bacteria produces toxin?
It's Shigella and Enterohemorrhagic E. coli.
Good. It is the Shigella and enterohemorrhagic E. coli. How does toxin inactivate the ribosomes?
It removes the adenine group from the 28S subunit of the 60S ribosome, inactivating it completely, stopping protein synthesis, leading to death.
Good. Now, what is the effect of toxin?
Firstly, sir, at the GI mucosa, it causes dysentery because there is it ends up killing the cell, so there is bloody diarrhea, and once there is enhanced cytokine release, all other organs are getting involved. If you take EHEC, which produces Shiga-like toxin, especially the O157 H7 serotype of it, it causes HUS, hemolytic uremic syndrome, where you have acute renal injury, then you have thrombocytopenia, and then you have hemolytic anemia.
Very good. How does enterohemorrhagic E. coli, earlier also I asked this, differ from Shigella, doctor?
Doesn't invade the whole cell.
EHEC does not invade the host cells. whereas Shigella does invade, which is the fundamental difference between the two. What is the mechanism of action of the two enterotoxins of the enterotoxigenic E. coli? Already we discussed this question. That is inflammatory toxin which activate adenylate cyclase and increase cyclic AMP, and heat stable toxin increase cyclic GMP. These are the 2 points to be remembered. Now, what are the bacteria that increase cyclic AMP? Also we discussed. Cholera, Anthracis, Pertussis, E. coli, Cape. Then what is the action of cholera toxin? Very good. So it activates the adenylate cyclase by activating the GS, leading to rice water diarrhea, is what you need to remember. So, what is the mechanism of action of anthrax toxin, doctor?
Like I said, sir, prevents phagocytosis by because of its capsule, and the exotoxins edema factor leads to edema around the issue. It mimics the cyclic AMP,
Very
so the
good.
lethal leads to necrosis.
So, which bacteria produce exotoxin that inhibits the protein synthesis?
It is Corynebacterium, Pseudomonas, and E. coli, Shigella.
Shigella and enterohemorrhagic. What are all the bacteria that produce exotoxins that increase the fluid secretion?
It is enterohemorrhagic E. coli and anthrax and Vibrio cholerae.
Which bacteria produce the exotoxins that inhibit phagocytic ability of the macrophages, our immune system?
It's Bordetella pertussis.
It is the Bordetella pertussis, which typically is the one which produces the exotoxins that inhibit the phagocytic ability. Which bacteria produce the exotoxins that inhibit the release of neurotransmitter?
Two things, sir, both belonging to the Clostridium family. One is tetany and botulinum. Tetany presynaptically blocks the inhibitory neurotransmitters like glycine and GABA, so leading to the muscle to be in continuous contracted state, leading to spastic paralysis. Whereas botulinum, it prevents the release of acetylcholine, so leading to weakness of the muscles cannot contract, so that leads to flaccid paralysis.
So, which bacteria produce the exotoxins that break down, that lies the cell membrane?
Firstly, it is Clostridium perfringens, alpha toxin of it, and Streptococcus pyogenes, which is nothing but streptolysin O toxin.
So, this is one of the favorite questions of the examiner. Alpha toxin is produced by the Clostridium perfringens, streptolysin O by the Streptococcus pyogenes. These two are notorious exotoxins that lies the cell membranes, is what you need to remember.
So just a small information here. Actually, sir, Clostridium perfringens, which is also called as veggie, that's nothing but the tennis racket which we see over the microscope. It has various types, sir. So A, B, C, D, E. And the most common type which we see in humans is type A. And that is producing alpha toxins, sir. It produces different toxins. One of the main thing is alpha toxin, which is nothing but an enterotoxin, leading to diarrhea, which is food poisoning, and there's one more called as hyaluronidase toxin, which actually leads to gas gangrene. And there is another thing called DNase, which kills the DNA of the host cell. So these are the main things about the Clostridium perfringens that we need to know.
Very good. So whenever a student prepares and teacher's job is only to facilitate, it's good for all of us. We study to go to the class. Teacher only become a study partner. So that is the whole idea. SK, Ganesh, Anamika, Sush, Sugan Joshi, and many more who are all online. I want all of you to be the part of this kind of a broadcast, which will help us to make it a more interactive session rather than a routine teaching and boring learning. So, doctor, which exotoxins are proteases that cleave the snare proteins which are required for the neurotransmitter release?
It is the Clostridium species again, sir. Tetany and Motility.
Which bacterial exotoxin lysis cell membrane? Once more, the same question repeated. The Clostridium perfringens, the alpha toxin, and Streptococcus pyogenes, streptolysin O. So, how we remember and reproduce in the tomorrow's exam is the challenge. Which bacterial exotoxin becomes a superantigen will create a cascade of reactions that lead to the development of the shock.
It is Staph aureus, which produces toxic shock syndrome toxin, and Streptococcus pyogenes, which produces erythrogenic exotoxin A.
Very good. So, uh, alpha toxin of Clostridium perfringens is a phospholipase, which is lecithinase, that degrades tissue and cell membranes. A lot of times this question has been asked, which toxin or whose toxin has a lecithinase activity? It is the alpha toxin of the Clostridium perfringens is what you need to remember for the tomorrow's exam. Similarly, there is a myonecrosis which occurred due to the Clostridium, and hemolysis, double zone of hemolysis on blood agar is also the feature which you see in Clostridium. Now, tell me some urease positive organisms. Fatafat, doctor.
The best way to remember this is Punchkiss, Punchkiss. So P is protease, U is ureoplasma, N is nocardia, C is cryptococcus, H is Helicobacter pylori, and then Ki is Klebsiella. The last two S are Staph epidermidis and Staph saprophyticus.
So once more, when they ask the question in INICET, you need to remember this by heart and reproduce in the exam, doctor. How does urease activity lead to stone formation?
Urease hydrolyzes urea to release ammonia, and that's what leads to formation of magnesium or ammonium phosphate stones called as two white stones, which especially happens with protease.
Very good. What is the function of catalase in the bacteria?
So, if there is catalase positive organisms, it produce. If you see on the picture, so over the slide, it produces bubbling. That is catalase positive, and urease positive is you see pink color. Negative is yellow. So in catalase, if you're putting hydrogen peroxide, it divide it. There's a chemical reaction because of the catalase. It cleaves it into water and oxygen, leading to that bubbling effect. And even before our body acts on the organism, it kills away the hydrogen peroxide, which is meant to kill the bacteria, hence allowing it to be free in our body. without being dead.
Very good. Now, fatafat bolo, Dr. Mithuna, what are the catalase positive organisms? 1, 2, 3, 4.
So how I remember this is, sir, LMN space. LMN space. So LMN, L is nothing but Listeria. M is Mycobacterium, sir. N is Nocardia. And then you have space. S is Staphylococci. P is protease is also there, so it's a part of it. And then A is Aspergillus, I think so. And C is Candida. And then you have E, which is E. coli, also Enterobacter.
Very good way to remember. Now, fatafat, tell me what are the pigment producing bacteria and what are the pigments which are produced by these pigment producing bacteria?
One which we have recently discussed, so you have spoken about pseudohemoptysis, that red pigment. It is Serratia marcescens, which produces red pigment. There is no hemoptysis, but because of that Serratia, that red pigment causes a pseudohemoptysis. And then you have Actinomyces israeli, which produces yellow sulfur granules, which contains the bacteria in it. And then Staph aureus has a golden yellow pigmentation. And then you have Pseudomonas, which has blue-green pigmentation. Blue is because of pionocyanin, and green is because of pyoverdin. Pyocyanin and pyoverdin.
Very good. A patient has a urinary catheter in place. He develops an infection. Which bacteria is the most likely culprit in this given clinical scenario, doctor?
Firstly, sir, Staph epidermidis is the one which is responsible for growing into the catheter. It produces that biofilm which is responsible for staying into the catheter, growing into it, and causing infection into the patient.
A patient with a history of dental problems presents with fever, heart murmur. Which bacteria most likely lead to this kind of infective endocarditis?
So it is Streptococci, sir, the viridin form of it, Streptococcus mutans and Streptococcus sanguinis.
So, viridin streptococci includes Streptococcus mutans and sanguinis, which are responsible in this given clinical scenario. A patient has cystic fibrosis, develops pneumonia. Which organism goes and colonizes cystic fibrosis patients, doctor?
It is Pseudomonas aeruginosa, sir.
Patient is wearing a contact lens, develops keratitis. Which bacteria is likely possibility?
It is Pseudomonas again.
A child has ear pain, fluid buildup behind the eardrum. Which bacteria is most likely responsible?
Hemophilus.
Actually, our regular joining them. So they have a gang of revision gang. So revision gang, um, who are very strong, committed to do revision. You'll remember more longer like this. Not only one teacher blabbering facts after the facts, no fun. Read and come, answer it, enjoy the revision together. Next time you don't need me. I'll give you the notes. One of you be the question asker, other be the answer maker. Bus, that's how the preparation should go on. So you all need to give me a feedback. Are you enjoying this kind of a group discussion kind of a revision, which is first time in the country? Always we are first in the country. We are the first to run video classroom first to give DVDs, first to live broadcast. So ultimately goal is how can we make this dumb preparation called NEET PG INICET more interesting, audio mantras, etc., etc. So thank you so much for all of you for being the part of this game, doctor. We will slowly pick up the speed. So we are now going a little slow. Yeah? Right. So it is the non-typable encapsulated H influenza is the most common bacteria leading to otitis media. So what is the significance of spore formation in bacteria?
It's mainly for the survival, sir, because the spores are very much comfortable in harsh conditions. It is resistant to chemicals, it's resistant to heat. Even in anaerobic environment, they can very much survive. They go into dormancy.
So spore formation is like lockdown period in for the organism for it to survive the harsh conditions. So why is autoclaving necessary to kill the spores?
Because it is highly resistant to heat and chemicals. Autoclave, the spore is exposed in autoclave for extremely high temperatures for a long period of time, because that is what it needs to be killed finally.
So what are the agents which are called sporicidal agents?
Hydrogen peroxide and iodine based agents are both sporicidal. They kill the spores.
Fatafat bolo doctor. What are some of the spore forming bacteria?
Everybody knows about anthrax, sir. Also in that family, Bacillus, you have Bacillus cereus, which causes food poisoning, and all the family of Clostridium, which is botulinum, difficile, perfringens, and tetany. All of them cause spores.
What is a protein which is responsible for the motility of bacteria?
It is flagella, and in that serotype of O157 head 7, so that head 7 nothing but represents the flagella, the name of the flagella.
What is the function of pilus, which is also called fimbria?
It helps in adherence, especially EHEC has pilus. So वो आके it attaches to the cell with the help of this pilus, and there is something called a sex pilus, which is there in positive organisms, which is F plus. So that helps in conjugation.
What is the chemical composition of the spore?
Uh, if inside you have DNA, sir, between the DNA you have this dipicolinic acid, and then outer coat of it is the peptidoglycan layer, and the last outermost coat is the keratin-like coat, which prevents it. It helps the spore to survive in harsh conditions.
Which type of bacteria can form the spores?
Just before we have seen some examples, sir. So only gram-positive bacteria can produce spores. That's what we're supposed to remember.
What is the function of spores? What is a bacterial capsule and what is it made up of?
So bacterial capsule, it's a layer which is made up of polysaccharides, rarely proteins. It protects the cell from phagocytosis.
What is the slime layer of organism?
Uh, it is the loose layer or the loose network of layer of polysaccharides which adhere to the surfaces, and it forms a biofilm. Especially now we have just seen an example, so staph epidermidis. So that also produces biofilm. It helps to stay in that environment and cause more ruckus.
Now, what are the components of the outer membrane of the gram-negative bacteria?
Sir, if you compare gram-positive and gram-negative, gram-positive layer is more thick, gram-negative layer is thin. But if you see number of layers, gram-negative is more number of layers. So gram-negative में एकदम अंदर, the innermost is the plasma membrane, so the cytoplasmic membrane, and then above it you have a space, you have a periplasmic space, and then you have a peptidoglycan layer, again you have a periplasmic space, and then outermost membrane is called as outer membrane, which has outer membrane proteins like porins and all those are available in outer membranes. This is gram negative. But if you take gram positive, sir, it has a plasma membrane inside, and above it, it has a periplasmic membrane or space. And lastly, it has peptidoglycan layer, which is pretty thick, sir. If you see the thickness, gram positive वाले बहुत thick है, but negative वालों में layers ज़्यादा है, but thin है.
Very good. What is the periplasm in a gram-negative bacteria?
Periplasm is nothing but that periplasmic space which I was talking about, sir. So whatever gets secreted into the cell, it's all getting accumulated into that periplasmic space. For example, like beta lactamases can come and wait there. So whenever you give beta lactam antibiotics, these lactamases are going to go and destroy it. So it's seen especially in gram-negative cells. They come and wait into that space.
What is the cell wall of the bacteria made up of?
Just like we just discussed, it's like the peptidoglycan layer. It is a sugar backbone with peptide side chains. It's like cross-linked, and it has a network-like structure, sir. So it protects the cell from an osmotic pressure damage. They're all like net-like.
What is the composition of the cytoplasmic membrane of the bacteria?
So cytoplasmic membrane is nothing but the plasma membrane which we are talking about. So that's the innermost layer. So it is composed of a phospholipid bilayer, which has proteins embedded into it. For example, like penicillin binding proteins and any other enzymes which is embedded into it.
So what is the function of cytoplasmic membrane of the bacteria?
It decides, so it's a semi-permeable membrane. So it decides what comes in and goes out of the cell. And it helps in transport. And it also helps in simple diffusion, osmosis, passive and active transport. It also is very important for endocytosis or exocytosis.
Now, a 35-year-old male presents with the UTI, urine culture is showing gram-negative rods, they are resistant to beta-lactam antibiotics, then which structure in this bacteria could explain this resistance that has developed?
So this outer membrane, which is the outermost layer of the gram-negative bacteria, so that is what is preventing, allowing the cell to be very much alive. And also, if they're producing lactamases, beta lactamases, that enzyme can go and cleave the beta lactam antibiotic. So that's what we can say. It's a gram-negative bacteria.
So what is the function of slime layer of bacteria?
That polysaccharides in that outermost layer, so they form a biofilm, which helps it to form a film inside the indwelling catheters, leading to more infection.
Now, if you look at the gram-negative bacteria, what are the components of the outer membrane of the gram-negative bacteria?
So if you specifically take outer membrane into consideration, we can divide it into three things. So innermost leaflet, there is a middle part, and then there is an outermost leaflet. The outermost leaflet has endotoxins, sir. LPS and LOS. LPS and LOS is nothing but lipopolysaccharide toxin and lipo-oligosaccharide toxin. LPS and LOS. And they also have embedded proteins, they have porins, and they have other proteins. Whereas the inner leaflet has phospholipids.
What is periplasm in gram-negative bacteria? Very good to see Meghaswana, 20 online classmates in our today's Jugalbandi. Ustad Amjad Ali Khan and Ghulam Ali Khan are having a double shot of revision. This is called as Guru Sishya Parampara, right? So it's a truly boring experience only when teacher is blabbering. Rather, a teacher-student together have a Q&A format of revision. It is altogether interesting. That is the idea. And I want more and more of you volunteering to come forward to join. And don't think Dr. Mithuna Joshi is expertise giving answers. From not qualified, she became 75,000 rank in the recent NEET PG with only 1 month preparation. So this time, whole night she need to sit and prepare and come to the class because whole world is watching. So a lot of times we pay fee, we go to 1,000 students sitting class. Half the time is gone for the boys to watch girls and girls to watch boys. Of course, that is necessary. But in addition to that, we should also proactively use our brain and enjoy learning. So that is the whole idea. Nice to see Hinopama Thakur and many more who are all online. So, Doctor, if this session is interesting for you, enjoyable to you, we can have it as long as we can. 4 घंटे एक स्टूडेंट का पेट्रोल खत्म और 4 घंटे दूसरे स्टूडेंट कपल बैठेगा और वो खत्म बाद में हम आएंगे. सो पूरा दिन भजन करते हुए हम रिवीजन कर सकते हैं. Ultimate goal is what, doctor? There are 50,000 Q&A audio mantras that you need to do the revision. So in our Spore learning app, you have all these audio mantras, whatever that we are discussing now. So no worries at all. So doctor, this is an interesting question. What is the role of lipoteichoic acid in the gram-positive bacteria?
So, dipicolinic acid is gram-negative, sir. Lipoteichoic is gram-positive. So, they're present in the gram-positive cytoplasmic membrane or the plasma membrane. They have TNF-alpha and interleukin-1. So, that's how they act over the host cells by causing destruction. Tumor necrosis factor and interleukin-1.
What is the difference in the gram staining between gram-positive and the gram-negative organisms?
I just told previously, sir, that there is a thick peptidoglycan layer in the gram-positive organisms. They retain the blue crystal violet stain of the gram staining, whereas the gram-negative, while the bacteria, it has a thin peptidoglycan layer. So whenever you put a counter staining, they lose it and they turn, because of the counter stain, they turn pink. So gram-positive is blue, gram-negative is pink over the gram staining.
Why some bacteria, you can't visualize them with the gram staining?
Just now, previously we discussed, sir, for that blue color to be visible, it has to be pretty thick. But When we come to certain organisms like Treponema, Leptospira, which are not visible on the gram staining, they're extremely thin. That is one thing. And secondly, if you take Mycobacterium into consideration, it has a very thick lipid content. So it has a thick lipid layer which prevents from the bacteria to take up the stain. So hence, even that is not very much visible on the gram staining. And if you take organisms which has no cell wall, for example, like mycoplasma and ureaplasma, cell wall ही नहीं है तो कहाँ से stain होगा? And then some intracellular organisms like Legionella, Rickettsia, Chlamydia and Bartonella, Anaplasma ehrlichia. All these are intracellular. So even that is not visualized over on gram staining.
So, SK is saying, Sir, Dr. Mithuna ko bolo, please finish entire microbiology today and today only and go. Otherwise, we don't let you go home. So, yes. So, around 22 years ago, when I was preparing for entrance, I only started the bad thing called coaching program. There was no coaching program, 1999, 2000. So all friends, we used to sit like this. And some guys like me, you are good in creating questions. Don't ask me to tell answers. And used to drive others to answer. So that is the only way that preparation will be interesting. And you will really perform so well, right? So what is the staining technique by which you can visualize chlamydia, rickettsia, trypanosoma, and borrelia?
It is the GMSA stain, sir, which we are using here.
So these microorganisms stain positive for genes. Good. Excellent. Megasphaena adds a very good point. Treponema, leptospira can be visualized by dark field microscopy. Very good, doctor. Why there is an inability for the chlamydia to be visualized by the gram staining?
So for gram staining, you need a peptidoglycan layer, which is absent in chlamydia because of muramic acid. And it is also an intracellular organism, so you can't stain it with gram stain.
Where do you use periodic acid SIF stain, doctor?
Uh, on and off, we have been hearing about it with the Whipple's disease, sir. So it is used to stain the glycogen, the mucopolysaccharides, to diagnose Whipple's disease, and it stains the Porphyria whipplei.
So PAS positive staining, Porphyria whipplei of Whipple's disease. What is Nielsen stain is used for?
Everybody knows this, it's mycobacteria. It's a carbol fusion stain, which is used to stain acid-fast bacilli, that is mycobacteria. Also, it is used to stain nocardia and protozoa, such as Cryptosporidium oocysts. It stains that mycolic acid in the wall.
What is auramine, rhodamine stain used for?
Auramine rhodamine stain is used to screen again for acid-fast bacilli, that is mycobacterium. It is more sensitive and inexpensive, but the catch here is the microscope is very expensive. Fluoroscope is very expensive when we compare it to light microscope. Even though the stain is cheap, the microscope is costly, and you can see that green yellow mycobacteria over the fluorescence microscope.
Which stain is used for Cryptococcus neoformans?
It's an India ink stain which is used for Cryptococcus neoformans. It's a negative staining. It means that it stains everything except what we want to visualize. So everything looks black, but what we want to visualize, the cell wall is looking like whitish. It looks like as if there is a white ring around it.
So India ink is like coaching study material. They give all the things that we cannot remember, right? What stain is used for thick polysaccharide capsule of Cryptococcus neoform?
So in the previous things, India ink doesn't stain the cell wall. That's why we're able to see it as white. It's a negative staining. बाकी सब stain कर रहा है, cell wall stain नहीं कर रहा है, India ink. But mucicarmine here stains the cell wall and it makes it look red.
What are all the microorganisms which are stained positive with the silver stain?
So silver staining is being used for H. pylori, Legionella, Bartonella, and coccidioids, Pneumocystis girovisi, Aspergillus. They're all stained positive with silver stain.
So, like a parrot, you should remember in the tomorrow's exam: Helicobacter pylori, Legionella, Bartonella, Coccidioides, Pneumocystis, Aspergillus fumigatus. They're all stained positive with the silver stain. What is fluorescent antibody and where do we use it?
Everybody is aware of FDA ABS stain, which is antibody staining for syphilis, which we do it for syphilis. And then other examples are Pneumocystis, Giardia, and Cryptosporidium.
What is the culture media which is used for isolation of specific bacteria called as?
So, firstly, sir, for Haemophilus influenzae, which causes otitis media in children, we use chocolate agar. And then for Neisseria, whether it is Neisseria gonorrhea or Neisseria meningitis, we use Thea Martin agar. And then you have for Bordetella, it is in the name, sir. Bordet Jengao. Bordet Jengao agar. You can also use Regan Louis. All that foreign, weird, tongue twisting names are being used for Bordetella. That's how I remember, sir. And then you have Tellurite agar, which is used for Corynebacterium. Even loafers medium is used for Corynebacterium, diphtheria. And then you have Eton agar, which is used for Mycoplasma. Eton agar, Mycoplasma, a cellular organism, and over that agar, it looks like a fried egg. So then you have McConkey. McConkey is meant for all lactose fermenting bacteria, sir. So whichever ferments lactose, it appears like pink colonies. It is also used to differentiate lactose fermenting and non-lactose fermenting bacteria, sir. So if they're not fermenting lactose, then they look pale, and if they're looking pink, so it means it's lactose fermenting bacteria positive. And then you have eosin methylene blue agar, which is for E. coli. E. coli can also be grown on McConkey agar. So. And then for all those Ella like Brisella, Franciella, Legionella, Pasturella, all those we're using charcoal yeast agar. So which is buffered with cysteine and iron. And at the last, fungi ke liye we're using Seborrheic agar. Then there is one thing for, I think, TB, so Lowenstein Jensen we're using.
So then that is one big ordeal to remember. One MCQ, sure shot, doctor, from one of these 10. What is the culture media which is used for growing Mycobacterium tuberculosis?
It is Lowenstein Jensen medium, sir. You can also use Middlebrook. And lastly, for broth cultures, we are using rapid automated broth cultures for the growth of the TB.
What are those factors which are specially needed for the growth of the H influenza?
Factor 5 and factor 10. Sir, I didn't understand what is this NAD plus in the bacteria in the brackets.
See, whenever H influenza need to grow, it need NAD plus as a cofactor. Similarly, it require hematin. So these two, if you provide, then there is a growth of Haemophilus influenza. So they gave some pet name, factor V, factor X. That's the only thing.
It's not 5 and 10.
It's not 5 and 10, factor V, factor X. What bacterial species produce the colonies with a green metallic sheen on EMB agar?
It is equalizer.
What happens to the colonies of the lactose fermenting enterics if you put them on McConkey agar when they grow?
So all the lactose fermenting bacteria produce acid, due to which the lactose fermenting positive bacteria all turn pink over the McConkey agar.
How does eaten agar provide for this cell wall less organism called mycoplasma?
Cholesterol is required, sir, for mycoplasma to grow on eaten agar, and that also looks like a fried egg over the agar plate.
A patient is suspected to have meningococcal meningitis. What culture media is used to isolate this very common cause of meningitis, which is meningococcal meningitis?
So as we know, sir, meningitis is most commonly caused by Neisseria meningitis. So Neisseria being the causative here, it grows on Thea martin agar.
A patient is suspected to have pertussis. What culture media is used for pertussis, doctor?
As we know that pertussis is caused by Bordetella pertussis, sir, and it grows on Bordet Jenga agar and that Regan Louis. So how I remember is Bordet. It's in the name Bordetella. Ek to yaad rahega. Another weird name Regan Louis, something Parisian name is also meant for Bordetella.
So we use Regan Love and Bordet Gengo's medium for Bordetella pertussis. A patient is suspected Legionnaire's disease. So Raghuvaran, is this more interesting? Pakka? We'll make you active participant.
Just now we discussed sir, all Ella, Bracella, Legionella, Pastorella, ये सारे Legionnaires disease cause करने वाले is Legionella. So that grows on the charcoal extract, which is buffered with cysteine and iron.
Doctor, if I had to pass you microbiology exam, tell me what are the anaerobes that you know?
Clostridium is there, sir. Bacteroids are there. Fusobacterium, Actinomyces, even Shigella, sir, is an anaerobe.
What are the anaerobes which are susceptible to oxidative damage?
So it means that they lack catalase enzymes. They're catalase negative. So they have no catalase for the bacteria to destroy hydrogen peroxide. So they're killed by it. So either they lack catalase or they lack superoxide dismutase. All the catalase negative are prone for it.
What is the characteristic feature of the anaerobes?
As the name says, sir, it's an anaerobe. It doesn't grow in the place where there is oxygen available. In that, you have both facultative and obligate. So, obligate is pakka wala anaerobe. Facultative is cat on the wall. It can grow either way. and they're extremely foul smelling because of the short chain fatty acids which they contain. They're also difficult to culture, and they produce gas like hydrogen gas or carbon dioxide, which leads to that foul smell in the tissues.
Why aminoglycosides are ineffective against anaerobes?
Because sir, aminoglycosides require oxygen, so they're only going to be affected over the aerobic organisms, but not the anaerobic organisms. They need oxygen for the antibiotic to enter into the cell, bacterial cells. So it is for anaerobes, it's not possible because they grow in an environment where there is no oxygen.
What are facultative anaerobes?
Just like I said that the cat on the wall, so they're यहाँ का ना घर का ना घाट का. So they may use oxygen as the last terminal electron acceptor to generate ATP, but also use fermentation and other oxygen independent pathways. So they can survive in both the ways.
So, doctor, what are the examples of the facultative anaerobes?
Firstly, it is streptococci and staphylococcus, and all other enteric gram-negative bacteria are also facultative anaerobes. If you take enteric bacteria which are gram-negative, examples are protease, serratia, E. coli, Klebsiella, Enterobacter, Citrobacter, Salmonella, and Shigella.
What are obligate intracellular organisms?
Obligate is pakka wale. They can't grow outside the cell, they're intracellular only. And they rely totally on the host ATP for its survival. Examples are Jasnavi's reds, Rickettsia, Chlamydia, Coxiella, all these are intracellular.
So, obligate intracellular are like younger sister who never went to hostel. She always stayed in the home, and we are facultative. All the facultative intracellular organisms.
These are the organisms which can survive even outside the host cell. They can also survive inside the host cell. And examples are Salmonella, Neisseria, Brucella, TB, Mycobacterium, Listeria, Franciella, Legionella, and Yersinia pestis.
So, what are the bacteria that wear clothes? Encapsulated.
First one is Pseudomonas, and then you have even Streptococci, pneumoniae, H influenza, all that encapsulate, especially in splenectomy cases, we'll give those vaccines, capsulated organisms. So that's how I remember. At least few like H influenzae, Neisseria, Streptococcus, and then you have E. coli, Salmonella, Klebsiella, and Group B Streptococcus, Pseudomonas.
So, what is the function of the capsule in an encapsulated bacteria?
It is anti-phagocytic, so doesn't allow phagocytosis, doesn't allow our host cell to identify that it's a bacteria, hence not getting destroyed into the host. And it is made up of polysaccharide and protein. Even the capsule without the organism in it serve as components required for production of vaccines.
So, how do we clear these encapsulated bacteria in the body? And what is the risk in splenics?
So, firstly, all these there is something called as complement activation in our body, sir. So, opsonin, that is nothing but C3b, which is being produced in our body, which is already there in minute numbers that increase. They go and attach to this capsule of the bacteria and tell the body, see, this is the bacteria. It's like uh, the main head policeman telling his constables to catch the thief. So the constables are going to catch the thief and say, "We caught the thief. Let's put him in jail." They're going to tell the main immune system that we have caught it. This is the culprit. So that is what opsonization means here, sir. And that's how they identify and finally kill. In asplenics, because all this destruction or this complement activation occurs in the spleen, they are at risk, sir, because they don't have this complement factors in the body. So we have to, after removal of spleen, we have to give them vaccines so that they develop immunity against this encapsulated organisms. And examples we have already discussed before. So, especially we have vaccines for Neisseria, meningitis, then you have Streptococcus pneumoniae, H influenza, pneumococcal vaccines. All these vaccines are given to the patient who has underwent splenectomy.
So many coaching centers advertise our dream faculty, but our advertisement is our dream study partners for your preparation, right? So you are not alone in the game, you get a dream study partner. Good, doctor. Now, what are the carrier proteins which are used by these encapsulated bacterial vaccines?
Some vaccines which have this capsule as an antigen, it is not enough for producing a good amount of immunogenicity. So this carrier proteins attached to the capsule help to improve the immunogenicity and promote this T cell activation so that we have a better vaccine production. As it is, only polysaccharide is not helpful. So it has to have a carrier protein for a better immunogenicity, for a better T cell activation.
Now, what are the examples of encapsulated bacterial vaccines?
Pneumococcal vaccine, sir, which is PCV13. Then it's a pneumococcal conjugate vaccine. And then you have PPSV23, which is also a pneumococcal polysaccharide vaccine. So, bada naam, bade number. That's how PP is polysaccharide. So, pneumococcal polysaccharide vaccine, which is 23, and conjugate wala is 13. Polysaccharide vaccine, pneumococcal, mein, there is no conjugate protein. And then you have H influenza type B, which is a conjugate vaccine. Again, you have meningococcal vaccine, which is a conjugate vaccine. Only different thing here is the pneumococcal polysaccharide vaccine without the conjugate protein, which is PPSP23.
So, what does the protein A, what does it bind to?
Uh, Protein A binds to the FC regions of the IgG immunoglobulin, and it prevents opsonization and it prevents phagocytosis. It's one kind of a survival factor for the bacteria, and it is especially expressed by Staph aureus.
So, what is the effect of protein A going and binding to the IgG?
It prevents opsonization.
The bacteria that expresses the protein A, doctor?
It is Staph aureus.
What is the function of IgA protease?
Protease, it's an enzyme. It cleaves the IgA, and you see IgA in the mucosal layer, in the respiratory tract, and in the gut mucosa. So it cleaves the IgA so that it can easily adhere to this mucosal membranes and produce colonies there and grow there. And it's secreted by Streptococcus pneumoniae, H influenza, and Neisseria.
So, what are the bacteria that produce IgA protease, doctor, once more?
It's H influenzae, sir. Streptococcus pneumonia, Neisseria.
So, what is the function of M protein?
So M protein, it prevents the phagocytosis again, and it is expressed by group A streptococci, whereas group B have IgA proteases. Group A has M protein. So that M protein is homologous. It is similar to the human cardiac myosin, which is the heart protein. And hence this group A streptococci are responsible for the rheumatic fever. It causes an autoimmune response in the body leading to rheumatic fever in these patients.
Which bacterium expresses M protein?
It is group A streptococci.
With whom M protein has a sequence homology, doctor?
It is the human cardiac myosin, sir. Molecular mimicry, that's what it's called.
So, what is the role of M protein in causing autoimmune diseases?
It causes an autoimmunity in the body leading to rheumatic fever, sir. Group A streptococci.
So, now we come to a very interesting area: transformation, conjugation, transduction. We need to be very clear. Examiner is going to give an image based question on this. Good to see 14 online classmates. In 1 hour, 12 minutes, we finished 120, right? 100 in 1 hour. Totally 1200 questions are there. 1200 questions in 12 hours. Microbiology, marathon race. अकेले बैठ के पढ़ना बोले तो रोना आता है.
I'll prepare it more better sir, tomorrow. Just getting the hang of it today.
You're mute.
No, I'm just thinking this.
So, what is transformation, doctor?
Transformation is like something you're changing into something very much new, sir. That's the word technically. But here in the microbiology, it means that there is transfer and expression of this newly transferred gene, which is also called as transformation. So you're transferring this gene and you're expressing it. That is transformation. So this competent bacteria, they can bind and import short pieces of the environmental naked bacterial chromosomal DNA from that bacterial cell lysis. It gets it and it expresses it over its body, which is nothing but transformation. Actually, transformation, sir, is very much helpful for development of multi-drug resistant bacteria. That is what is getting involved here, is what I think it is.
So, what are the various bacterial virulence factors?
So one is the capsular polysaccharides, sir, preventing phagocytosis. Protein A, again preventing phagocytosis and complement activation. IgA proteases causing cleaving of the IgA, allowing the colonies to grow over the mucosal membrane. And then you have M protein, which mimics the cardiac myosin, leading to autoimmunity, causing rheumatic fever in that patient.
What is a capsular polysaccharide?
So, capsular polysaccharide is nothing but what is responsible for preventing phagocytosis. It's highly charged, it's hydrophilic, it is water loving. It acts as a barrier to the phagocytosis and also complement mediated lysis. So, it doesn't allow the complement to come and lyse it, it doesn't allow the macrophages to eat it. And it is also one of the major determinant of the virulence factor of the bacteria.
SK is asking, sir, are these 1235 points are enough for INICET? How does SK know it? They are 1235? Oh, if you go to the, no, if you go to the Spore app, if you go to audio mantras in the microbiology, you have all these mantras, but not as articulate a voice as Dr. Mithuna or anybody, Raghubaran. So, but the point is, this is a precursor for that. Absolutely, more than enough SK. If you mastered this 1235 points. You can start microbiology crash course. I will conduct. Anybody can come and join. 50% discount, you can say, right? So uh, today there are so many so-called national faculty, blah blah blah. उसका photos लगाते, एक T-shirt डालते, right? Brand का. But what is important is, doctor, how much you are preparing, how much you are actively recalling, how much you are assimilating, how much you are reproducing, how much you are enjoyably learning. That is important, doctor. It's not that this and that flashy course. Interesting question. Transformation. What is transformation?
It is getting that part of the cleave that gene and expressing it on its own body.
Now, what are those bacteria which are capable of transformation, doctor?
The bacteria notorious for transformation are Streptococcus pneumoniae, H. influenzae type B, and Neisseria.
What degrades a naked DNA, preventing the bacterial transformation?
It is the DNase, the full form is deoxyribonuclease, which cleaves that naked DNA, whichever is moving into the environment.
What is F positive, F negative conjugation?
So before we just spoke about pilus cell, which is responsible for conjugation. So whoever has the plasmid, which has this sex pilus, it is F positive. Which doesn't has this pilus is F negative. And F positive, this bacteria, the sex pilus on the F plus gets in contact with the F minus, and there is a single strand of plasmid DNA, not chromosomal DNA, plasmid DNA, which is transferred across this bridge, which is called as a conjugal bridge, or it is also called as a mating bridge.
If there is a transfer of, can a transfer of chromosomal DNA can occur? Does it occur in F plus to F minus conjugation, doctor?
It is the plasmid DNA which is transferred, but not the chromosomal DNA.
So what is HFR to F minus conjugation?
So this F plus plasmid, which has that sex pilus on it, it can become incorporated into the bacterial chromosomal DNA, and it is termed as a high frequency recombination cell, HFR, high frequency recombination cell. So F plus plasmid is getting incorporated into the bacterial chromosomal DNA. Transfer of this leading part of plasmid and few of this chromosomal genes occur, and a high frequency recombination cell is formed.
Whenever there is a F plus to F minus conjugation, what is the role of a F plus plasmid in that?
Because the F plus has the sex pilus, that is the main thing required for the conjugation. So if the bacteria lacks it, it is F minus. So it has not much of role. बुलाने में F plus की जिम्मेदारी है, तो yeah, F plus has to work for it.
So ultimately, what is the process of F plus cross F minus conjugation?
The sex pilus on the F plus contacts the F minus. A single strand of the plasmid DNA is transferred across the conjugal bridge. But there is no transfer of chromosomal. अगर ये chromosomal चीजें हो रहे हैं ऐसा, then it becomes a HFR cell. That's different.
Whenever HFR to F minus conjugation is happening, what happens to the F plus plasmid?
that F plus plasmid becomes incorporated into the bacterial chromosomal DNA, and it is called as a HFR, which is a high frequency recombination cell.
Now comes transduction. What is transduction, doctor?
In short, it's a packaging error, sir. So, where this lytic phage, it infects the bacterium. The phage comes and infects the bacterium, leading to the cleavage of the bacterial DNA. Parts of that bacterial chromosomal DNA may become packed into the phage capsule, and this phage infects another bacterium, transferring these genes. So पहले ये phage आ रहा है, it is sitting on the bacterium, it is causing cleaving of the bacterial DNA. It's going to collect all that cleaved parts. It takes up into the plasmid, then it goes and infects another bacterium, carrying that infected genes. That is what is called transduction.
So there is a generalized transduction, specialized transduction. So doctor, tell me what is specialized transduction?
A specialized transduction is where an excision event, where lysogenic phage, again, it comes and infects the bacterium. Then that viral DNA is incorporated into the bacterial chromosome. Ulta ho raha hai. Bacterial cleaved DNA is not going into the plasmid, but that viral DNA is getting incorporated into the bacterial chromosome. When the phage DNA is excised, flanking the bacterial genes may become excised with it. So whenever this phage DNA is getting destroyed, even the bacterial genes might be excised. Then this DNA is packed into the phage capsid and can infect. यहाँ पे क्या हो रहा है sir? It is like viral DNA आके it's getting incorporated along with that genes and the genes of that excised bacterium. Both of this are getting mixed up, taken up by the plasmid and getting infected. That is being carried for infection of another bacteria. That is what is called specialized transduction. In plain transduction, it's just the cleaving of the bacterial DNA, but not the plasmid DNA.
Tell me five bacterial toxins which are encoded by the lysogenic phase A, B, C, D, S.
So ABCDs are A is for group A streptococci, which is nothing but the enterogenic toxin, and B is botulinum toxin, C is cholera toxin, D is diphtheria toxin, and S is Shiga toxin.
So what is transposition, doctor?
As the name itself says, sir, there is a change of the position. So a jumping process involving a transposon, which can copy, excise itself, it can separate, and then go and insert into the same DNA molecule at another place, unrelated or an unrelated DNA also. Example is plasmid or a chromosome, which is transposition. It is reading it, copying it, leaving that DNA, getting attached on the same DNA at another place or into another unknown DNA. That is transposition.
How is transposition is critical to create the plasmids which have multi-drug resistance and it can be transferred across the species lines?
So I understood this process is, sir, the bacterium is reading the antibiotic which we are giving. Now that information has reached the bacterium. This transposon reads that part, excises itself, gets attached on the same DNA or another DNA, telling the bacterium that we have to develop a resistance against it. So this transposition is what which is involved for multi-drug resistance in the bacterium. And one of the examples for it is TN 1546 with Van A from Enterococcus to S. aureus. What is Van A? So is it vancomycin?
Fundamentally, they are all the specific genes which decide the drug resistance, basically. Yeah. Now, what are exotoxins?
So toxins are two types, exo and endo. Exotoxins are extremely potent. Even a very minute dose, like 1 microgram, is enough to cause issues. But whereas endotoxins are very weakly immunogenic. So you need a higher amount of endotoxin for it to produce issue in the body. This is the major difference. So exotoxins are toxins, the proteins which are secreted from certain species of gram-positive and gram-negative, which have a high toxicity level. If fatal dose is as less as 1 microgram, and it is typically located on the plasmids or the bacteriophages.
What are the typical conditions caused by exotoxins?
They can cause major diseases like tetanus, diphtheria, botulinum, cholera. All these are exotoxins which are causing huge issues into the human host cell.
What are endotoxins?
Endotoxins are a part of the bacteria itself. They are the part of the outer cell membrane, mostly gram-negative bacteria. But they have a very low toxicity level. So even the fatal dose, for a fatal dose, it needs a very higher amount for it to produce issues. So hundreds of micrograms is required for it to cause a problem in the human body.
So, what are the typical conditions which are caused by endotoxins, doctor?
Endotoxins can cause diseases such as meningococcemia, and it can lead to even sepsis because of the gram-negative rods. So these are two examples for endotoxins, sir. Till now, whatever we have read is all exotoxins. All bade diseases are exotoxins.
What is the chemistry of exotoxins?
Exotoxins are nothing but polypeptides, sir.
What is the chemistry of endotoxins?
Endotoxins are composed of lipid A component of the LPS, nothing but lipopolysaccharide. They don't have proteins in it, sir. It's a lipid and polysaccharide. But exotoxin is a proper polypeptide.
What are the genes for exotoxins? Where are they located?
Exotoxins are located on the plasmids or the bacteriophages. But endotoxins are a part of the outer membrane of the bacteria itself.
So, where are the genes for the endotoxins located typically?
The name endo came because they're located on the bacterial chromosome. That is what is expressed over the outer membranes being excreted into the host cell.
What is the antigenicity of exotoxins?
Exotoxins produce high titer antibodies, which are called as antitoxins. Very 1 microgram is enough.
How about the antigenicity of endotoxins?
Endotoxins are poorly antigenic. You need a very higher number for it to cause problems.
What is the main mode of action of endotoxin?
Endotoxins work with effect by TNF alpha, tumor necrosis factor alpha, interleukin 1 and interleukin 6.
We successfully finished our first round in 1.5 hours. And how come Raghuvaran is seen on the top? Oh, that is a background image. So next time, what we will do is four of us will, three more students sit. One question. Like that, it will be very fast and interesting also. You did you prepare for the second? Ready? Tomorrow. Both of you should participate. Then that will be more enjoyable. So second part, are you ready? We finished only 150 out of 1200.
I got a hang of it, sir. I'll be able to finish two more parts by tomorrow. So anybody interested from the online family of yours?
Oh no, they can't. Second also you prepared, no?
No, sir.
No? Okay. So once more, thanks to all of you for joining this wonderful evening, Doctor. And we do one thing. You still have time now, only 7 o'clock.
Yeah.
We'll finish AIMS question bank of general medicine, where we left, right? For a short while before we call it a day, right? Nice. So online students should give a quick feedback how you liked this Jugalbandi, right? We are relatively faster comparatively, because in 1 hour, almost 1.5 hours, we are able to finish 150. Come on. We should reward ourselves for this experiment. If you take, for example, surgery division, surgery is after all 6,000 Q&A. 6,000 Q&A. We require 40 hours to sit like, no, 40 hours to sit like this.
We go more fast.
We can really go more faster, actually. Yeah, definitely.
Today is just the day one class, so I was not understanding how we're going to do it.
Pattern.
Now that I know, so I can prepare two more parts. We can finish these.
Absolutely. Absolutely, doctor.
This is coffee for the repetition.
Last time, so doctor, let us take up the minor topics in general medicine in the past 22 years of the AIMS INICET. Commonest cause of the death in primary amyloidosis typically is caused by cardiac involvement. So most common organ involved in amyloidosis is kidney, followed by liver. And how do you establish the diagnosis? 70% of cases of amyloidosis, it is the gingival and rectal biopsy. Renal amyloidosis, it often recurs. Even if you do renal transplant, whenever a patient had a renal failure, renal involvement is there with amyloidosis, even if you do renal transplant, once more in the transplanted kidney also, amyloidosis will recur. So it's a normal patient, whereas a patient in whom there is an amyloid deposition into the interventricular septum. Senile cardiac amyloidosis is because of the deposition of the amyloid. And what is it basically? It is transthyretin. So you know, doctor, this is another batti marne wala item hai. AL type of amyloid in primary amyloidosis, ATTR in familial amyloid neuropathy and senile cardiac amyloidosis, ApoA1 in familial amyloidosis, beta 4 in trisomy 21, beta 4 in Dutch cerebral amyloid, A beta in Alzheimer's, then calcitonin responsible for amyloidosis in medullary carcinoma of thyroid, and beta 2 microglobulin is responsible for hemodialysis associated amyloidosis. Is the list that you need to remember, doctor. 80-year-old female present with progressive loss of memory, difficulty in reading, difficulty in speech, irritability, neurofibrillary tangles. What is the most likely possibility? It is the beta amyloid is what you need to remember. So, whenever there is medicine questions, miscellaneous questions, I mean minor topics. So these are the neurofibrillary tangles, amyloid plaques, which you see in case of Alzheimer's. So the next favorite topic is androgen insensitivity syndrome. A 16-year-old girl with primary amenorrhea but a normal sexual development in the form of normal breast, but absent pubic and axillary hair and bilateral inguinal hernias. It is the androgen insensitivity. What is the karyotype in that, doctor? XY. In spite of that, what is happening there? Testosterone is unable to act on receptor level resistance. So that becomes translated into estrogen. The moment estrogen is there, breast is there. That is the reason there is a development of breast development. There is no axillary pubic hair. And if you happen to evaluate, typically he will have XY. And there is an undescended testis which presents like a inguinal hernia is what you need to remember. So this is another example where there is a development of breast in case of androgen insensitivity syndrome. So female external genitalia, 46XY karyotype, inguinal testis, absent uterus, primary amenorrhea, absent sexual hair, normal breast development, vaginal hypoplasia. The combination is what you see in case of testicular feminization syndrome. Once more, when we discuss gynecology, fatafat, you must be in the answering end to answer. So what I am telling all the online students, doctor, we have totally 40,000 Q&A in the form of audio mantras. Check yourself whether you are able to. Nobody is needed to teach, actually. What is there to teach? If you get any doubt, you have Google to explain you. But the problem is what? We go to a coaching guru thinking that he will give you some focused material, right? And some motivation because he is shouting using his vocal cords. You use your vocal cords. Sit with your friend. Open the audio mantra. Dum, 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 dum. Can I recall the answer without listening to the voice prompt? So that is what you need to practice and you will become the topper. SK is saying, sir, these questions are out of medicine PDF. Sorry about that. I will send you the PDF. Don't worry. Now, a baby girl, once more, bilateral inguinal mass, thought to be hernias. What karyotype? X1. So this is how typically the bladder, the rectum, right, and with inguinal masses. So these are the typical testes which are not yet descended and a blind pouch like blind ending pouch like vagina. Next, acute tubular necrosis. What is the commonest side effect of cisplatinum in a patient using it for esophageal carcinoma, doctor? Typically, platinum compounds will lead to the development of tubular toxicity. So this is the typical cisplatin injection. So tinnitus, deafness, neuropathy, hyperuricemia, and renal toxicity because of the tubular epithelial cell damage are the features of cisplatinum is what you should remember. Renal damage because of the amphotericin B, what will happen? Exotemia, renal tubular acidosis, hypokalemia, hypo, not hyper, with amphotericin B. So exotemia, hypokalemia, this is a very frequent MCQ. Amphotericin leading to hypokalemia. Because of tubular dysfunction, they lose the ability to concentrate the urine. So they develop isostenuria. Whether you are dehydrated or whether you are overhydrated, same specific gravity urine will be produced. That's called isostenuria. Nephrotoxicity caused by amphotericin B is dose related and it can be reversed by the stopping of therapy. Necrotizing papillitis, this you should answer. Many times I asked you. Necrotizing papillitis, what are all the causes like a parrot? Papillary necrosis, beta.
Diabetes, salicylate poisoning.
Very good.
PNH.
And renal vascular thrombosis. Sickle cell anemia. Not in PNH. So this is how papillary necrosis. What are the typical appearance on nephrogram? If you pass contrast, ring shadows, ring nephrogram, right? You need to remember. So this is how typically you can see, doctor, this is the necrotizing papillitis and ultimately developing pus in the kidney, which is pyonephrosis. So if you happen to do the biopsy in the renal cortex, you can see necrotizing papillitis. This is another example of necrotizing papillitis. So diabetes, sickle cell disease, chronic daruwala, vascular disease, NSIs, urinary tract obstruction. And what do you see on pylography? Ring shadow is what you need to remember for the tomorrow's exam. Ring shadow. Then what is that called? Egg in cup appearance. This is also called egg in cup के अंदर egg के जैसा है. This is another example of ring shadow. Can you appreciate? So another example of 53-year-old with analgesic nephropathy with a ring shadow is what you need to remember. This is another example of a pyelonephritis patient. Pyelonephritis is also a risk factor for papillary necrosis. Papillae means minor calluses who separate. So this is another example where you are able to see the ring shadow egg in cup appearance. Then comes the next topic, carcinoid. Carcinoid typically produce a valvular disease mainly in, see, carcinoid, where do you find ileum? Ileal carcinoid. So ultimately, all the blood of the gut will pass through mesenteric vessels, ultimately reaches the IVC, goes to right side of the heart, and when tricuspid valve is there it will lead to vegetations on tricuspid valve. So this is the important echo doctrine. Right atrium, left ventricle, right ventricle. So in the right atrioventricular valve is tricuspid valve. In that you are able to see the vegetation which led to regurgitation. Hence you are seeing Rangoli. The back moving blood, front moving blood have got different colors, front, forward flow, backward flow. When dono milega to Rangoli milega. So this is another example where between right ventricle, right atrium, you are having the tricuspid valve which is showing the presence of vegetations. Metastatic carcinoid. Right? So tricuspid regurgitation. जरा आगे बढ़े तो right ventricle and pulmonary artery के बीच में pulmonary stenosis. And it is metabolized to monoamine oxidase, which is present in the lung. So that's the reason by the time it reaches from the right side to reach the left side to go to systemic circulation, already serotonin of the carcinoid is metabolized in the lung. Carcinoid tumor is most common in appendix. Then generally rectal appendiceal carcinoids infrequently metastasize. Ileal carcinoid metastasizes very often. And most common symptom of the carcinoid is intestinal obstruction. Then comes the cardiac tamponade. So today morning I posted some audio mantras, right? So take opportunity. So everywhere mantras. Young motorist suffered injuries. Blood pressure was 80/60. Heart rate was 140. He is restless, tachypnic, jugular veins are distended. Air entry is adequate in both the lung fields. Heart sounds are barely audible. Lung sounds are audible means it is not pneumothorax. If it is pneumothorax, then intercostal drainage tube is needed. Why you are saying fixation of left ventricle, left femur? Because that can lead to fat embolism. But this is not fat embolism because there are no petechiae on the front of the chest or any of the features. So that is the reason this requires urgent pericardial tap. So whenever cardiac tamponade is there, what is the Beck's triad? Beck's triad. Beck's triad is lot of fluid around heart. It will compress the heart. What is the hallmark? If you do 2D echo, you have to demonstrate diastolic collapse of ventricle. So whenever diastolic collapse of ventricle is there, at the time of diastole, ventricle is supposed to get filled by atria. It is not filled. If it is not filled, it cannot pump. If it cannot pump, you get hypotension. And JVP is not able to drain into the heart. Because JVP need to drain into right atrium and ventricle. But ventricle is not letting it to push the blood. So you should remember, heart is surrounded by full of blood, full of blood. And jugular vein want to drain into right atrium. Right atrium want to drain into right ventricle. But this full of blood is causing collapse. When collapse happening, atrium cannot drain into ventricle. So that is the reason jugular vein is prominent. There is a hypotension. Muffled heart sounds. If you put stethoscope here, what will you listen? Nothing. Already you are wax plus fluid around the heart. So together. So what is this, doctor? This is the liver. This is the right atrium, left ventricle, left atrium, and between left. This is left ventricle. This is what? Right ventricle. So right ventricle is completely collapsed because the fluid around. So what is this called? Leather water bottle. Leather bottle. They say Lawrence of Arabia movie. Have you seen? Lawrence of. Recently, have you seen this movie? A man named Otto. Wow, beautiful movie. Tom Hanks is my favorite, all-time favorite. Right? So Otto. So this is like Lawrence of Arabia ki leather bottle configuration. Desert में जाते हुए उनका होता ना A shape में होता. And lot of, see, this is heart. This is what? Fluid. So this is the elevated JVP, muffled heart sounds, low blood pressure, Beck's triad. हाँ, इప్పుడు చెప్పండి. JVP में X descent क्या होता है, Y descent होता है? Absent. Why does Y descent occur? Y descent is fall of the pressure in jugular vein. I mean, on the atria. So, when the ventricle diastole occurs, the blood gushes from atria into ventricle rapidly. That will cause the fall. But here, it is not letting it to fall. So, absent Y descent. But X descent is very prominent. So X descent is happening. So always a descent occur from one point to another. If that point from where it is falling is already at a higher pressure, which happens because of the fluid around, X descent is prominent. But Y descent is absent. Y descent absent, X descent exaggerated. That is cardiac tamponade. X descent exaggerated, Y descent also exaggerated. That is constrictive pericarditis. Agreed? So you can see here, tamponade. What happened to the X descent prominent, Y descent absent? Here, constrictive pericarditis, X descent steep, Y descent also steep. Is called constrictive pericarditis. Right? Now, doctor, which is least likely to lead to constrictive pericarditis? Rheumatic fever is a fibrinous pericarditis but never leads to constrictive pericarditis. What is the most common cause for the constrictive pericarditis? हम इस देश के वासी हैं जिस देश में टीबी बहती है. टीबी. Ramaya, Sitamma, Buchakka, Lachava, they will all have TB with constrictive pericarditis. When Ramaya is walking into the OPD only, you can recognize his constrictive pericarditis. How? If there is a constriction around the heart, right? The jugular vein Normally what happens during inspiration, negative intrathoracic pressure will be there. And what will that do? It will suck more blood into heart, atrium. So jugular vein normally collapses during inspiration. But here क्या हो गया? This constriction will prevent that inspiratory sucking of the blood and collapse of the JVP. So JVP without collapsing remains prominent. Inspiration ले लो, expiration ले लो, भागो, बैठो, कूदो, कुछ भी करो. So Ramaya will be walking with a prominent jugular vein. He'll have ascites. He'll have ascites. Why ascites? Because from the liver, hepatic vein drains into IVC, that is draining into right side of the heart. If the right side of the heart is not letting any blood come inside, then all the blood is stagnant in IVC and that lead to ascites. So all ascites are not due to cirrhosis. Just because it's a villager, you thought it is cirrhosis. So Ramaya will say, so whenever ascites is seen, what is the temptation? Sister needle, push, what will come out? That feeling should be there when the acidic fluid is coming out. So Ramaya will say, don't put that needle, sir. So many people put in my village. They are saying no liver problem. He will only tell you. So all ascites are not due to liver. Ascites can be due to cardiac cause, which is due to constrictive pericarditis. And an intelligent third year MBBS student just freshly studying Hutchison's clinical method said, why this prominent jugular vein, this ascites is equal to constrictive pericarditis? That day I heard in audio mantra. So the mantra will come and he will make the diagnosis. What is the cause of rise in JVP with hypotension? Cardiac tamponade. Inca. Right ventricular MI or even heart failure. All of them lead to rise in JVP with hypotension. Similarly, restrictive cardiomyopathy, right ventricular MI, constrictive pericarditis, cardiac tamponade, right heart failure, all of them lead to increased venous pressure and with the hypotension as a combination. Then comes cardiomyopathy. What is the cause of restrictive cardiomyopathy, constrictive cardiomyopathy, hypertrophic cardiomyopathy? Three types of cardiomyopathy. Alcohol is dilated cardiomyopathy. Amyloidosis, restrictive cardiomyopathy. Three most common causes of restrictive cardiomyopathy. Radiation after you do open heart surgery, myocardial fibrosis and amyloidosis.
So all fibrosis leading conditions
Will lead to, and infiltrative conditions. Scleroderma, amyloidosis, sarcoidosis, Gaucher's, Hurler, Fabry, hemochromatosis, glycogen storage, myocardial fibrosis, carcinoid, any metastatic malignancy, radiation, anthracycline, which is used in breast carcinoma. So I have one of my patient, Sridevi Reddy. Huh?
Even doctor Robinson causes some heart issue.
Sridevi Reddy. She had a breast carcinoma. Her both sons are from IIT and settled in America. So they give a call, doctor, my mama is having shortness of breath. So she is a 10-year back survivor of breast carcinoma. Anthracycline she was received. So now she was in fact the fourth or fifth case of restrictive cardiomyopathy I managed. So don't forget, after a few years it can also come, restrictive cardiomyopathy. So a non-compliant ventricle, not able to stretch, resistant to diastolic filling, is typically restrictive cardiomyopathy is what you need to remember. So one of the favorite questions of the examiner, doctor, what are the differences between constrictive and restrictive cardiomyopathy? If you look at the pericardium, it's normal because restrictive cardiomyopathy, all the problem is there within the myocardium's ability to stretch. Constrictive means myocardium is okay, but surrounding pericardium is thickened. Atrial enlargement is very severe in restrictive cardiomyopathy. So, mitral valve and tricuspid valve typically will show regurgitation. So, the respiratory variation it is called. It is more in constrictive pericarditis. Ventricular septal motion is normal. Interventricular septum is there, no ventricular septum. The motion of it is normal and restrictive. But constrictive may, normally what will happen whenever the inspiration, more venous return comes into the right side of the heart, that will make the interventricular septum to move into left side, and the left side filling become decreased. So output become decreased and pulse become weakened. But if there is a constrictive pericarditis around, this phenomena become exaggerated. There is little blood enters more during inspiration, then immediately more amount of pushing of the right ventricle interventricular septum into left side happen, that lead to such a significant fall of the pulse that pulse will be absent. What is that called? Pulsus paradoxus. Heart is beating but pulse is not felt. That is what you see in bronchial asthma, constrictive pericarditis, etc. Normally only during inspiration there is a decrease in pulse, strength of pulse, because the interventricular septal movement from the right towards left, because inspiration brings more blood into heart.
So, but you just said that.
That is in tamponade, not in constrictive pericarditis. No.
But
Constrictive pericarditis.
is the person who walks in, you said that.
Diastolic collapse of ventricle is a feature of.
No, sir, not the diastolic collapse. Overall, the venous return is less collapse. So why do we have exaggerated movement of the ventricular septum?
That's what. Whenever the constriction is there, the inspiration brought outwardly negative pressure become exaggerated when there is a constriction. So that is the point. And left ventricle ejection fraction is significantly decreased in restrictive cardiomyopathy. So how do you differentiate between the two? You do the biopsy of the cardiac muscle. So endomyocardial biopsy will prove that this is restrictive cardiomyopathy, which is otherwise normal. Heart is normal in constrictive pericarditis. It's only the problem of the outer pericardium. Is what you need to remember. So, doctor, a 45-year-old woman underwent a modified radical mastectomy 4 years ago, treated with multiple bone metastasis with cyclophosphamide, doxorubicin, which is a risk factor for drug-induced cardiac toxicity, doxorubicin. Cardiomyopathy, what are all the conditions where you see it? Type 2 glycogen disease, Friedreich's ataxia, Duchenne's muscular dystrophy. Once more, stupid things that we need to remember. This is what dilated cardiomyopathy, daru wale mein. So dilated, hypertrophic, restrictive, erythmogenic, unclassified. This is the broad division of cardiomyopathy. Ultimately, when you do DM cardiology, very few things will remain. हम इतना पढ़ के जाते ना, Why do you need all these things if you are going to become a dermatologist? Right? Or ENT surgeon? Too much. Toxic doses. Ideally, what they should do, no? They should, just like super specialty exam, they need to, you want to take MS ENT, then you take a ENT special exam. Once upon a time, it used to be like that. But anyway, now they made it, SK is asking, sir, how will I differentiate arrhythmogenic ventricular dysplasia from constrictive or restrictive? First of all, between constrictive and restrictive, you know, endomyocardial biopsy, right? So, doctor, idiopathic infections, ischemia, toxins, drugs is all dilated. Hypertrophic can be concentric, as what you see in hypertensive, uncontrolled hypertension. Or it can be eccentric, mid-cavity, apical, septal. Then restrictive is amyloidosis, sarcoidosis, hemochromatosis, endomyocardial fibrosis, and radiation. Right? Then Taco Subbo, stress-related cardiomyopathy comes under unclassified cardiomyopathy. Teapot. थोड़ा emotional हो गया तो they will arrest. So that is the story, doctor. I think हम 2 घंटे 10 मिनट पढ़ के मजे में पढ़ाई किया. So doctor, this is only beginning. We'll try to start at 10 o'clock. By 1:32 तक खेलते खेलते पढ़ाई करेंगे. मैं 1 घंटा लास्ट में पढ़ाऊंगा, 3 घंटे Q&A, and do finish the revision. So please finish, otherwise SK will be very angry. He expected today only to finish all Q&A, right? Am I right, SK? But sleep well, don't be awake till 5 o'clock. I don't believe for these 300 slides you are awake whole up to 5 o'clock, right? So early to bed, early to rise makes you healthy. And playing one round of football like our Raghuvaran. 3 hours play, na? At least as much you play football, that much if you sit and study with Mithuna, I promise that you will get seat, right? So thank you all, and we'll see tomorrow. Thank you.
Thank you.